Hey guys, it's Ben from Pragmatic Software Engineering. I can't wait to get started on this. We're going to be talking about classes today. When we write code as programmers and we're writing object-oriented code, we try to conceptualize how things work, and we extract this into something called a class. So as an example, I have a cup here, right? I could make a class called cup and it has some sort of liquid in it. It's a silly example, but this is the way we build our world or our framework, our world in programming. Now, for us, a class is about important as a noun to the English language because it allows us to define what an object is, what type it is. Classes are like a blueprint. So when you create something using a blueprint, that's called instantiation. Let's drill a little bit harder into that. Here's an example. You are a human. I am a human. But we are not the same human. My name's Ben. Yours could be Kevin. I live in Boston. You could live in Nebraska. Instantiations are from the same class, but they are a different, I don't want to say instance, but they're a different sort of entity that gets built from that class. Let's go along the lines of creating a person with code. Now, before we even write any code, we have to talk about what constitutes a person. What is a person? Well, we have to talk about their attributes first. And some of their attributes may include their age, their eye color, their height and weight. We can represent some of these, except the eye color, with numbers. We may want to understand who their parents are and what their home address is. So right there, we've just analyzed what a person is. And we've talked about things that describe them, attributes. If you rewind all the way back to when we first started talking about programming, these are variables, but they're attached to a class and they're called attributes. But they're just variable. But a person is not only defined by their attributes, they're also defined by their capabilities. Now we call these methods, and these methods are just what we talked about in the first episode. They're just functions. And these methods can produce a result. So an example of things that can do, or things that are a method without a result, are walking, breathing, jumping, doing taxes, reading. And some things that do produce a result would be like cooking dinner, or asking a question, or drawing a picture. So we've talked about what a person is and what a person can do, but we have not talked about how to create a person. Now it's 2021 and we haven't figured out how to yet create a person without a father and a mother. So the way we do this in programming is we expose a special function called a constructor. And this constructor is described in the class. So we'll create a person constructor for person. And what he will do is he will consume a father and a mother. So you will provide a father and a mother as arguments for this constructor, and then you will create a person. This is an example of we require some information before we can create an instantiation of the class. Let's get started on building a class. Now, we'll do a different example. We're going to create the concept of a Jedi. Specifically, we're going to be creating Luke Skywalker. Now, here you see this is a description of the code we're going to write. These are called comments, and comments are denoted by the //. Comments are wonderful because they never get compiled, and they live in the code. So a lot of times we use them to describe how things will work, describe why we did it, or just other things you need to know about in the code. So we're going to create Luke Skywalker, and he has parents Anakin and Padme. Hope I spelled that right. Luke also has a skill level, and he can ask himself if he's ready to fight Vader. We know Luke is ready to fight Vader when his skill level is over 4, and Luke can train to increase his skill. Now we know what we need to do. First, we have to build the class. There are multiple ways to do this. So I like to use Shift, and then type new class. Additionally, let me pull up this. Here, you probably have something on your left here that looks like this. And what you can do is you can right-click and create new Java class. We'll call him Jedi. I'm going to pull this over or close it just so you can see the code in my lovely face. So we've talked about that a Jedi has a father and a mother. We also talked about them having a skill level. We'll represent this with an integer. It'll start at 0, just because I want to be explicit about that. We talked about how in order to have a Jedi, we need parents, right? So what we do is we create a public constructor that's just the name of the class. It's always the name of the class. It never has a return type or anything. It's just the name of the class. It's going to be a function, and what we're going to do is we're going to have defined a father, a mother. Before we move on, I gotta say this because whenever I write code in at my job, I will use the same exact name as the variable name, and what I could do is like this dot father equals father. Let's say this is just, I changed this to father. This dot father, I'm pointing like you can see. This father, like this attribute of the class, will be set to this parameter because we describe this. This means the class we are instantiating, or the class that's running this code, saying this attribute, this father attribute, is equal to this argument here. Because that can be a little confusing, I'm just going to rename this just so it's super explicit. Oh, I did that wrong. And if I didn't want to set the skill up here, I could set the skill here. This is just purely a code style thing. So now, let's go back to main. And let's create a new Jedi. We use Anakin as the father and Padme as the mother. And I'm just going to create a new reference. Just call this Luke Skywalker. Okay, now I love to use system.out.println to print out values to double check things are the way they are. So if we're going to do this, I want to print out Luke Skywalker's father and Luke Skywalker's mother. And we should see Anakin and Padme below here. Oh, we do. Awesome. Let's get started on a method where Luke could ask himself if he is ready to fight Vader. I'm going to go back to the Jedi class. By the way, what I just did there was control-click on the class, and it will bring me to the constructor, because I clicked it on the constructor. Okay, I'm going to create a public function that returns a Boolean, because we're going to ask, is ready to fight Vader. And we know that if the skill level of the Jedi is greater than 4, we can return true, or we can return false. I can't wait to show you guys this thing. This is what makes me tick here. This is a way to do this. This is a really, I would say, clunky and non-sophisticated way to ask if the skill level is greater than 4. One thing I want to show you here is, think about this logically. If the skill is greater than 4 and we return true, returning means we don't run any of the following code in the function. We just immediately stop the function, and this, what I've highlighted, never gets run. So this else isn't required either. Let me put this here. So we still, but this is a little bit better, but this still could be refactored to be a little bit cleaner. So we've talked about Booleans before, and Booleans are a statement that are true or false. So we can actually get rid of this if statement, and we have a statement here that is a Boolean. It's true or false. We get rid of this if, we replace it with return. Now we have a tiny piece of code that does exactly what we've described. This is like an example of refactoring code that maybe a little bit too verbose into something that's crisp and clean. Now we have a way to ask if we're ready to fight Vader. I'm going to save it. I'm going to go back to main. We're going to ask, are we ready to fight Vader? And of course we're not, because we haven't trained Luke at all. In fact, we might be interested in even knowing what Luke's skill level is. It probably should be 0. It is 0. So we have to give Luke a way, or Jedi, I suppose, a way to increase their skill level. And once again, we're going to write another function, but because there's no result of this, we use the keyword void. And we're going to call this train. Train doesn't have any arguments. We don't need to have any arguments to train. What we're going to do is we're going to set skill is equal to skill plus 1. And again, I deliberately did this way because this is the most logically spelled out way. If I wanted to do this in another way, what I could do is I could actually do skill plus equals 1, and that's shorthand for skill equals skill plus 1. And I can do it once better. I could do skill plus plus, which equals, if you expand it out, skill equals skill plus 1. Another example of refactoring code that's verbose into a crisp and concise piece of code. Let's go back to main. We're going to have Luke train, and the semicolon, get out of here. Actually, this doesn't return anything; it's a void. So we're going to say Luke train. All right. Now we expect Luke to have a skill level of 1. The semicolon. It always gets me. 10 years of programming, it's still getting me. Okay, our training level, or our skill level, was at 1. So Luke's still not ready to fight Vader, but if we have him go to 2, 3, 4, 5, now let's print out his skill again. He's at 5. Now let's see if he's ready to fight Vader. Oh, yes, he is. Awesome. Now let's take a once-over of our Jedi class here. Let me get rid of this. So we have a package statement. We have a place where this code lives. We have a public class Jedi. We'll get into what public, private, protected, what they all are. I just feel like it's not a good idea to talk about it at this exact moment because it may confuse you. But anyways, public class Jedi, we're going to encapsulate all of our code here, if you notice, in these curly braces. Now, Java uses curly braces to kind of establish a context here, and so you're seeing we're establishing a context of the class here. We have a string father, we have a string mother, and we have an integer of skill, which will be 0 by default. And we've described a way to build a Jedi through a constructor, specifically a public constructor. Again, I'll talk more about this when we get to directories and package structures. We consume, in order to build a Jedi, we have to be given a father and a mother, and we set our attributes to be the constructor parameters. If we got rid of these, there would be no father and no mother. The class would never have set the father and mother to be the actual values that we set them to. And we set the skill to be 0. We create a method that returns as a Boolean, and it's called is ready to fight Vader, and it returns true when our skill level on our Jedi is greater than, 4. And we've also created a method that produces no results. It doesn't return anything, and it is called train, and it adds 1 to the skill of our Jedi. And that, my friend, is a class. Classes start as something simple as a Jedi, but they can get into these really esoteric things like, let me see, clients, flows, adapters. I'm deliberately using words that may confuse you because I'm trying to show you that you can take classes from these very small and easy to understand notions and begin building more complicated classes that really make programming a lot easier and a lot more manageable in the programmer's mind. I hope you enjoyed this video today. Please leave a message if you didn't think it was helpful or you still are confused on something. Please like the video and show it to your friends, of course, and subscribe. Thank you very much.